know whether this was a 100Q,
yeah,
which is just down to 0.4, or whether it's a 230, which will go down to 0.04.
Okay, so this is an LS100Q, and this will go down to
0.4 of a micron.
0.4 of a micron. Okay. Can we have a quick look inside it?
Yep.
Okay, and what's this thing here that we're looking at?
This is the sample cell. This is where you place your sample.
Yeah.
The laser beam is situated there.
Okay, yeah.
Laser will come through there, along there, through the sample, and then the sample will diffract the light. It's collected by these collection lenses here, and there are some detectors that sit behind there to pick up the diffraction pattern. That's then sent back to the computer, and the computer does a calculation to produce the sizes for you.
Okay, right. And again, just to refresh my memory, the size range that this will deal with again?
Will be 0.4 of a micron up to 850 microns.
0.4 to 850 microns.
The 230 will do 0.04 to 2000 microns.
Okay, right. So, okay, and if we could have a quick look inside that, is there a sample in there at the moment?
There is. You won't actually see much in there because the dilution at which you have to run the sample is relatively low.
Okay.
So you may just, depending on your eyesight, see the odd particle whizzing around, but
no. Right.
yeah, basically if you can see it, it's too concentrated.
Okay. Right. So what do we do next to run a sample?
Okay, having put the sample, basically, you can use any liquid, including water and sunflower oil. Liquid fills the cell up, you put your sample into there, screw the lid down.
Okay.
Pop it in there.
Yep.
Adjust the stirrer. Shut the lid. And on the software, there is an option on here which is run cycle.
Yep.
Ignore those. Enter sample information. Run settings and start. Run. Start. I'm trying to save it to a folder that doesn't exist. This is the sample information, so I can just put in a test sample, for example.
Yeah.
Click OK. If I want it to run for 60 seconds, I can do a number of runs there, change the number of runs, and then I'm going to untick the save the file so the error doesn't come up, but I can save the file. I can automatically export the data and print the data. Just put it down there, and then off it goes, and there are 57 seconds before it finishes, and the size distribution is displayed on the screen, and it will adjust slightly as it gathers more and more data. And you can actually display on the screen some stats in real time.
Okay, right. And you can archive this data? Or?
Yep.
Yeah.
You can plot trend graphs, you can overlay graphs. You're doing the samples. If you want to repeat this in 5 minutes' time to make sure it's a drug, for example, dispersion is stable, you can repeat it, not a problem, and then overlay the graph so you can see it hasn't changed.
Okay. And liquid samples, no problem with that module there. If we wanted to do a powder, how would we go about doing that?
There is a dry powder module that fits on the front there.
Okay. And that would just fit into the front of that?
Yeah, it sort of actually stands externally with the cell that fits in there,
but what you could do is dissolve powders in some form of solvent or whatever, couldn't you, of course, as well, if you wanted to do that.
That's basically...
And that's it, is it?
Just about finished.
Great, so what's that telling us? Okay.
Okay, so it's saying that the mean size is 136.8.
Yeah.
Median's 134.4. The D10 is at 80.86. D90 is at 201. And the calculated specific surface area is 531 centimetres squared per gram. And we can look at different stats if we wish. We can display the graph, we can look at cumulative graph rather than the differential. It's once you've acquired the data, how you present it is really almost unlimited in terms of the Windows options, colours and graphs.
Well, that's great. Let's get another quick shot of it. Lovely. Right.